Okay, so let's take a look at the Chapter 7 notes, Part 5, and we'll do the first couple pages in this video. So in this one, we're trying to solve for variables that are stuck in the exponents, and in each of the equations in number 1, there are exponents on both sides. And so the goal is to try to do these without a calculator. All of the ones on this page are doable that way. And you notice that in the first one, the bases are the same. So if it's 2 to the something equals 2 to the somethings have to be the same. So x plus 1 would have to be the same as 3x minus 3. And if I bring this x over here, I'll get 2x. And if I add 3 to both sides, I'll get equals 4. So then x ends up being 2. Okay, so there's the first one. That's pretty simple. In the second one, the bases are different, but we can kind of rig it so that the bases are the same, because 4 is really 2 squared. So 4 to the x is really 2 squared to the x, and that equals 2 to the x plus 1. And then when I have a power to another power, you just multiply them. So that's 2 to the 2x equals 2 to the x plus 1. And now the bases are the same, so I can set the exponents to be equal to each other. So 2x equals x plus 1, and if I subtract x from both sides, I just get that x is 1. Okay, let's take a look at the next one. So I've got 4 to the x equals a half to the x minus 3. So I'm going to rewrite this as 2 squared, and I'm going to rewrite this as 2 to the negative 1. So this one becomes 2 to the 2 to the x equals, and this one becomes 2 to the negative 1 to the x minus 3. And then I've got a power to a power on the left, so I multiply those and just get 2x. And on the right, I multiply the negative 1 with the x minus 3, and I get negative x plus 3. And now the bases are the same, so I can make the exponents the same. So then 2x equals negative x plus 3. If I add x to both sides, I get 3x equals 3. And then if I divide by 3, I get x equals 1. Let's look at D. So in D, it's a 9 and a 27. And you can probably figure out, well, 9 is really 3 squared. And 27 is really 3 cubed. So the key is trying to find a number that you can work with, like a key value. And in this case, it's 3. So this one, power to a power, I'm going to multiply those together and get 3 to the 4x. And then the same deal over here, I've got power to a power, so I'm going to get 3 to the 3x minus 3, because I'm multiplying this times that and this times that. And now, since the bases are the same, the exponents are equal. And I can subtract 3x, and I'll get x equals negative 3, and there's that answer. In E, I've got an 81 and a 1/3 as my numbers to work with. And 3 is going to be the key number here, too, because 81 is really 9 times 9, which is 3 times 3 times 3 times 3. So 81 I can write as 3 to the 4th, and then that's all to the 3 minus x. And 1/3 is really 3 to the negative 1, and that's to the 5x minus 6. And now let me do power to a power. So I've got 3 to the 12 minus 4x when I multiply the 4 into the 3 minus x. And then on the other one, I've got 3 to the negative 5x plus 6. Now the 3's are the same, so I can say 12 minus 4x equals negative 5x plus 6. If I add 5x to both sides, this side just becomes x, and if I subtract 12 from both sides, I get negative 6. So there we go. So let's take a look at the next page. The next page is ones where you would need a calculator, essentially. So here's the example. Now, I solved it 2 different ways. One way is what we've already been doing. If I give you 2 to the x equals 5, you can convert that using your calculator. Or you can convert that using the rule, log base b of a equals c means the same thing as b to the c equals a. So if you convert it, you get log base 2 of 5 equals x. And then this you can just plug in on your calculator and end up with 2.319. Well, That's because our calculators have that nice log base feature on it. But most calculators don't. Like if you're using an iPad calculator or a TI-83, or most calculators don't have a log base, but a lot of them have a button that just says log on it. That's the same thing as log base 10. And that's the only one that it has. And that's been true for years, actually. In fact, I think the log base thing only came out a couple years ago. So the way around it was actually to use the regular log button. And what you would do is you'd say 2 to the x equals 5, and you just rewrite it, but you take the regular log of both sides. And then there's this rule for logs that we learned that if you have log base anything of something to a power, the power comes down in front. So then that x comes down in front, you get x log 2 equals log 5. And then you just want to solve for x, so you divide both sides by log 2. And if you typed in log 5 over log 2, you get the same answer that you got before. Okay? So we'll try each method a couple of times. Let's do number 2. So first one, 9 to the x equals 35. Let's just use method 1 for this. So method 1. Method 1's typically the one you're going to use anyway because you have the special calculators that have that base. But we'll do method 2 a couple of times just to practice. So this one, 9 to the x equals 35. If we rearrange it, it becomes log base 9 of 35 equals x. And then we just need to type that into the calculator. So let me get that started. Why does this always take twice? There we go. Okay, so alpha f2 log base 9 of 35. And we get 1.618. Okay. Now, if we'll just do this one both ways. Method 2. 9 to the x equals 35. So imagine for a minute that the only button you had on your calculator that was related to logs was the regular log button. So all you can do now is take the log of both sides. Okay, now the nice thing about this is that power will come right down in front. And we get x log 9 equals log 35. And then to get x by itself, we're just going to divide both sides by log 9. So it's log 35 over log 9. So regular log 35 divided by regular log of 9. And there you go, same answer. X equals 1.618 right there. Now, it turns out it doesn't matter what base the log is that you're using when you take the log of both sides. I could have used ln. If I used ln of 35 divided by ln of 9, natural log, same deal, right? 1.618. If I really wanted to, not that I would recommend doing this, I could do log base 7.2 of 35 and divide it by log base 7.2 of 9, and you're still going to get the same thing. It doesn't matter what the base is, as long as you're taking the same base of both sides, the same log base of both sides. Okay, let's try B. So in B, we've got, well, let's isolate that term to get the x term by itself first. So if I add 5 to both sides, I get 2 times 7 to the 9x equals 20, and then divide by 2, so 10. And at this point, if we use method 1, I'll just write m1 here, then that's going to convert into log base 7 of 10 equals 9x. And then we can plug that into a calculator. So alpha f2 log base 7 of 10. That's 1.1839 equals 9x. And then I'm going to divide both sides by 9. So that'll become 0.1315, let's say, equals x. Okay. Now if we had used method 2 instead, so I'll just write method 2 here. if we'd started, no matter what, we're going to go from that step. So 7 to the 9x equals 10. And then we just take the log of both sides. Log of 7 to the 9x equals log of 10. And then the 9x comes down in front. So I get 9x times log of 7 equals log of 10. And then I'm going to divide both sides. So 9x will be log 10 divided by log 7. So log 10 divided by log 7. So 9x equals that thing. And then you're going to have to divide by 9. And you get the same answer that you had before. X ends up being 0.1315. Okay, let me shrink this down so I got a little more room. Okay, so C, we'll just do method 1. So C, if we rearrange this guy using that log to exponential form rule, then this is just going to be log base 5 of 120 equals x. Well, that we can just type in. Log base 5 of 120 equals 2.975. There we go. All right, and then I think there's one more here. Let's see. Yep, one last one. So this one, the whole thing here is the power. So if I just convert it right away, it's log base 5 of 120 equals 2x plus 4. So in fact, we can just solve for x leaving it like this. Log base 5 of 120 minus 4 equals 2x, and then we'll divide both sides by 2. So then x equals whatever this junk is. So let's type that in. In fact, we already have log base 5 of 120 right there. So I'm just going to do minus 4, enter, and then divided by 2, enter. And that's going to be negative 0.5127. There we go. If you wanted to do it all at once, I would probably recommend doing alpha F1, numerator over denominator, and then the log base thing. So that's 5, log base 5 of 120, all minus 4, and then all of that divided by 2. Let's see if that works. Yeah, there we go. Same answer. Okay, I hope that helps a little bit.